This is a machine learning project in which we are trying to predict the housing pricing using existing data set. So we are making a machine learning model which can accurately predict the future prices for the Boston housing. For that we are using Python as a tool. So there are total 5 steps for final prediction. One is data processing, pre-processing. The second step is to split the data between training and testing data. Training data will be used in step 3, where we are going to train the existing created model, and then in the final step we are going to test it using the test data set. So this is how we are going to do it. First we prepare a Python before we start the project. We are using this Jupyter Lab notebook. You can see import numpy. This is to arrange and manipulate arrays, and then we are going to use pandas for data framing and data manipulation. Matplotlib is used to plot the obvious graphical data and animated graphs in Python. Then sklearn provides us with the Boston data set, and it also gives the mean squared error from which we are going to make a loss function. Then we split data using the train test split. It is also available from sklearn, and minimum maximum to normalize the data. Then we are going to use HTML display to display our graphs. So first step is data pre-processing. So we load the Boston data set in the Boston variable. Then we see what data is about using the boston.desr function. It says that there are 506 instances and total 13 attributes, and all the attributes is like CRIM, SEDN, Indus, RM. It is a different feature which affects the pricing of the housing. So we have all this data available to us as a data set. So what we are going to do is we will first make a data frame using panda data, and we are going to collect all this feature data in the feature variable, and these are the feature names, and these are the 506 instances. Now we are going to identify relation between whatever our target is and with individual features. So once we have a data frame which is a feature, we also have another data which is called target, and the target is the final pricing information which we have. We are going to use this target to judge our data model. So we are going to extract target information from main data set, and then we can find out a minimum and maximum using the Python functions. Then we are going to merge these two. We are going to concatenate these two data frames, feature and target, side by side. So we put axis is equal to 1 to do that, and this is how we concatenate the data. And finally we have a data set which is complete with the features and target that we want. It has a 506 rows and 14 columns. Now we can also describe this data frame. That means it will create a snapshot which calculates the mean, standard deviation, minimum, maximum data from the data set, and it will display for each features and target. This is just for our understanding of the data. Then we are going to calculate the correlation between each and every column using df.code, and we are going to use Pearson method. But we are not interested between correlation between two features. We are interested in the target and the feature. So we are going to create another data codes which will give us the final target correlation between target and features, and we are going to make L as a list which contains this information. We are going to sort it in the descending order so we can see it which one is the maximum in the graph, and this is how we are going to plot this bar. Now we can see that L state has a maximum correlation. It might be negative or positive, doesn't matter, but L state is the maximum correlated feature with the target. So we can use this to make our model. L state is the statistic of the lower income household in the area. So whatever when this L state value is higher, the target price is going to be lower, so it is a negative correlation. So we can see some of the data using print functions, and we can find out so we have absolute data. We are going to do scaling, minimum and maximum scaling, and then we are going to use fit transform to reshape the data so that we have all the data between 0 and 1. This will help us to normalize data before we start processing on it. Second step is to define error. This is a cost function or a loss function, and this is the way we are going to find out what is the difference and what M and C is going to give us the nearest value, and what is the error with that nearest value. This is the function we are going to use to define that error. Then we split data of the existing data set. We are going to split 20% to 80%. 80% will be used to train our model, and 20% to test its validity and predict the make the prediction from this model. Now we'll need an update function which will update with a learning rate incrementally so that we know in which direction our prediction is going. Okay, and we are going to use gradient descent, linear regression gradient descent to calculate the error, and then update will decide the direction and the step. We are not going to use larger steps so that it may skip some of the information and may go in the wrong direction, or we are not going to make our learning rate so small that it takes too much of time. So we have to come with a normal or means optimum learning rate so that our model can predict make a prediction in minimum resources. Okay, so now we are going to run this model that we have made. Our model is built up of three things: error function, update function, and gradient descent. Okay, so we are going to run it with some initial values, and we are going to see what it predicts, what value of M and C it predicts, so that M and C is decide so that we can predict our future housing rates. Okay, so we'll start with some initial value, and then it will roll in the direction that gradient descent takes it, and then finally it comes with an optimum value where error threshold is as defined by us. Like here we have decided 0.001. So whenever it is below 0.001, it says that M and C has achieved its desired value. Now once this gradient descent is run, we'll have M and C new value, error values, and MC values. We can display these things using the error visualization, and here we can see that the red line is the function that we have obtained from running our model, which predicts and have the similar type of pattern as our target value has. So we can saying this, we can see that this model has predicted correctly the function, has given the output of the function, which can very accurately, not very accurately, but almost like with error of 0.001, it can predict the future values of the housing. If we plot these errors which we have calculated, you can see that after 60th of iteration, this more iteration doesn't make any more improvement. So while we may also reduce our iteration from 250 to like 100 or something, and we will have the similar kind of result. It will save a lot of processing power also, but we have no idea of knowing that before we start running this model, right? So now we have a function, a model which gave us output. We also can see how this training was done, and we can visualize it using update frame function and live animation plot in the Python. You can see here, see this is how it started calculating with the negative descent, negative slope, positive slopes, and then it turns step by step and fits exactly where we want it, right? So you can see that this is working very fine with the model we have built. So when the prediction and training is when training is over, we can start our prediction. The final step is the prediction. Now model has been completed. We can predict the target value using the test sets. Okay, so we first calculate with existing MNC which has been calculated and see what prediction it is done. Then we find out the error between actual value and the predicted value to see how accurate this is, and then we can also put a data frame in which target value and predicted value is compared side by side, so then we can properly analyze the result. This result can also be predicted and targeted value can be plotted simultaneously, so we can visually see what has been done. And finally, but this result is still in the normalized value, so it is between 0 and 1. In real world this value doesn't mean anything, so we have to reverse transform this information to the actual values that we have in our data set. So we will revert normalization and we will reshape these whole values, and then we will have a final value, and we can then make a data frame which displays all the information in single table. This displays the X value, which the feature we have used, the target Y, which was actual housing pricing, and this is what we have predicted. You can see this is very similar value. Our model predicted very accurately what will be the housing values. This finishes the project of the machine learning. Thank you.